would like to welcome you to the SPE webinar organized by SPE Hydrogen Technical Section. As you all know, SPE is the biggest individual member organization for oil and gas specialists that is existing for connecting oil and gas professionals and to enhance their professional competence with the help of different resources and programs. As you know, also SPE has different sections, technical sections, and SPE Hydrogen section is one of them. That exists for people that have deep interest in the development of hydrogen technologies. SPE Hydrogen Technical Section has 10 officers and more than 1,000 members, and these 10 technical officers of the technical section is working with the leading chair of Chris Kelly, to develop these programs that can satisfy the needs of each member. So my name is Yurii Moroz. I am a program chairperson for Europe at SPE Hydrogen Technical Section, also SPE Central Ukraine Section chairperson in Ukraine, in my local section where I'm located right now. And this volunteering goes above my work with UGV, this biggest gas production company in Ukraine, and I'm responsible for new energy projects development. So why we all gather here? It's my pleasure to introduce you Dr. Anders Ødegård with the presentation topic, large-scale production of green hydrogen and case studies for its application. Short bio, Dr. Anders Ødegård is a senior project manager at SINTEF, one of the Europe's largest non-profit R&D institute. I was happy to meet with Dr. Anders 1 year ago, to discuss the hydrogen issues, and I'm more than happy enough to cooperate at one of the projects with Dr. Anders Ødegård and SINTEF R&D Institute. So during the presentation, you can add, comment, any questions or comments in the chat. I'll be pleased to read it, and Dr. Anders will try to answer your questions. So the presentation will be distributed if Dr. Anders is okay. And be aware that we are recording this webinar in order to upload it after to the SPE Live library. That's all from my side. Therefore, Dr. Anders, thank you very much for accepting our proposal to find a time for this presentation that could be very interesting to our SPE members and members of SPE Hydrogen Technical Section. So we were having more than 100 plus people that were registered to this webinar, and almost half of them are now present at this call. So thank you all that you registered, that you came. We hope it will be very productive and interesting. Dr. Anders, the floor is yours.
Thank you, Yurii. Also, thank you for the invite. I'm very happy to be here and present. So looking forward to today's presentation and also questions and comments throughout. So happy to stay on board until the end of the day. Let me first of all share my screen. Did you? Okay, so assuming now you see my screen. If not, somebody's
we can see.
Out. Sounds very good. Okay, so as Yurii says, I'm here with SINTEF, having worked with hydrogen for many years, a couple of decades actually, and we'll now share some of our activities and experience from the electrolyzer or green hydrogen value chain. First of all, a very brief overview of what I will talk about. So introduction, I guess we're more or less beyond that now with Yurii and myself. I'll say some words about SINTEF, what we do there in the area of hydrogen in general, then come into electrolyzers, both on the technology and also on the market, some information on the potential use cases and demand of hydrogen, and then towards the end look more into business case analysis from one of the demonstration projects I'm coordinating. So it's refined 2. Summarize, and then I assume there will be time for some Q&A at the end. Yeah, briefly, SINTEF. So we're one of Europe's largest independent research organization. We're non-profit, so all our earnings go back into the business, developing new infrastructure, new competence for industry. We have our seat, as I said, in Norway. We're in Trondheim and Oslo mainly, but we serve customers and partners worldwide. We're a large presence in Europe when it comes to the hydrogen projects. Our vision is technology for a better society. So we cover a wide range and much of science and research development within that. We're located here in Trondheim at the university, NTNU. So we have a very tight collaboration and integration with activities on the research side, education side, and joint projects with them. Our sorry, I'm just gonna stop one window. As said, the areas we cover are sort of along all sciences and technologies. When it comes to sustainability and innovation and future transformation, which we need when it comes to sustainable global progress. And I'm not going to go through all of these in detail. Some of these are relevant for hydrogen, some are not, but we cover much of the hydrogen value chain and related sciences and aspects of that. So within hydrogen, we are at SINTEF a couple of hundred people who are involved in that in one or the other way. They might not be 100% activities on hydrogen, but their competence is relevant to the hydrogen area and are then integrated in some of our projects. I'll come back to that later on. Very brief on the background of hydrogen. I'm sure all or most of you are aware of current situation, sort of the increased interest and efforts put into hydrogen as energy carrier and also fuel and input factor for industry within, and then the need for hydrogen in that respect. So this figure tries to illustrate the sector coupling and the unique aspect of hydrogen, that it couples all sectors when it comes to heat industry, mobility, similarly as some of the fossil fuels does today, and that's the strength of hydrogen. It can be used in a variety of settings. Increased focus on this. It's seen that hydrogen is required to reach some of the global emission reduction activities. So there's a wide range of applications and use cases where electrification, direct or via batteries, cannot be implemented. So this is where we see a huge need for hydrogen and an increased need of volume and expansion of the value chains and actors who are involved in this. Back to SINTEF. Very briefly also here, what we do So we cover the whole value chain, looking into all the way from materials, basic research and development, up to more modules, components, and systems, as well as full-size plant demonstrations. And we also do circular economy analysis and also LCA studies on this value chain. And along all of this, we do modeling as well, different kinds of tools. So on the low TRL level, up to more applied tools, which can be used to analyze and design components and controls of systems. So that's one of these tools which I'm going to talk about today, what we are using for this electrolyzer business case analysis. So in green hydrogen or hydrogen in general, so you have production and consumption of hydrogen. So now I've sort of started backwards with fuel cells for consumption of hydrogen in this sense. So we do lots on fuel cells development. Here you see 5 projects which go along the whole value chain, as mentioned to you, sort of component and material development in our labs. Then we are joining more hardware and modeling activities as well, up to the range of the H2 Accelerate truck project. I have one more slide on that later on, where we, together with large OEMs like Daimler and Volvo and Iveco, are deploying 150 hydrogen fuel cell trucks within the next years. And along that, we also have fueling station providers like Shell and Total Energies. On the electrolyzer side, it's similarly. So we are involved in many EU projects here, also along the value chain, from materials, components, up to systems and pilot demonstration. I'm going to talk to you about the 10 and 100 megawatt PEM electrolyzers at the Shell refinery in Germany. 10 megawatt is now operating at Energy and Chemicals Park in Rhineland, and the 100 megawatt plant is being designed and planned for. Also, based on the activities we do, we have established a separate electrolyzer company, which is called HyStar, with a new concept and technology for PEM electrolyzers. We have a test facility here in Trondheim and Oslo, so it's on high and low temperature fuel cells and electrolyzers. It's, we say at least, the most advanced in Scandinavia, with utilizing our core competence that we can go into the basic principles and fundamental scientific aspects of fuel cells and electrolyzers. Here as an example on what we do on stack tests. So might not be too familiar with all of you, but here to the right are some examples of fuel cell providers where we have a cooperation and have their fuel cell stacks and cells in our labs. Below here is an example or a picture of one of the hydrogen trucks we have here in Trondheim. So we have 4 hydrogen trucks running in Trondheim, which is built by Scania with a supplier of fuel cells from Hydrogenics. Diagnostics, also an important aspect both in electrolyzers and fuel cells. So we develop tools, do analysis on systems running, and improve then how to operate in a strategic good way these systems. Here's also an example of where we do similar things. So there's a 2.5 megawatt electrolyzer system built up in the very northern part of Norway, where it's directly connected to a wind park. So it produces up to 1 ton of hydrogen per day, And the plan has been to look into this as a demonstration up until they're expanding this to fit the potential wind park plans, where they already can increase up to 200 megawatts for a hydrogen system, with the plans to develop some production of, for instance, ammonia in the area, which can be then supported. The good thing about the northern part of Norway, it's lots of winds, high capacity factor. I think it's about 4,000 hours, which is almost double of what is the average in Middle Europe. So in that sense, the electricity is very cheap, and you can have a low-cost hydrogen based on that. Perhaps a bit more relevant to the petroleum industry is activities offshore on hydrogen. So we have activities with Technip FMC, who are developing a concept and project called Deep Purple. This is where you have offshore production of hydrogen and also re-electrification through fuel cells, which is then planned to supply offshore installations with stable electricity. This can also be used on the coastline where you have a weak grid or little access to electricity. I mentioned the Accelerate Trucks project. So here, together with partners, we're developing a deployment plan and hardware to demonstrate the use of hydrogen fuel cell trucks along the whole Europe. So we're gonna deploy trucks from Italy in the south up to Norway, Sweden in the north. The plan is, this is a project running up until 2029, and we will start deploying trucks already next year. Related to mobility and hydrogen, so there's activities on the quality of hydrogen. So you're probably also aware of the different sources of hydrogen. So electrolysis, which is the topic of today, is mainly very pure, but you have other sources of hydrogen from, for instance, reformed methane, SMR hydrogen, where there might be remaining sulfurs and carbon compounds, and for some usage these impurities might be detrimental for operation. So for instance, on the fuel cell side, on mobility, so it's very important to check the quality of hydrogen. So what we do there is to look into sampling on the fueling station and do analysis of this. And then also based on that, we can go back again to the fuel cells. What impact does that have on the performance and durability of it? So those are then again important aspects. Also related to petroleum engineering is pipeline. So you might also know that Norway have lots of natural gas pipelines subsea to the continent, and there's an interest in using these for hydrogen as well, either new pipelines or repurposing ones. So there's a difference in onshore, offshore, or submerged and on land, and these are activities which are very much ongoing now, and there's huge investments being done in developing this in mainland Europe. When it comes to subsurface pipes, there's a different or a more severe issue with impact of hydrogen on the pipeline. But this is something which is being done both in Norway and other countries, and also collaborative. So for instance, we take in samples of used pipelines and do analysis of them. Yeah. Also related to more industrial and large-scale use, you have hydrogen safety, of course. I assume that's a dedicated aspect or topic which is being discussed in the forum we're in now. And two projects to mention here, which are ongoing in Norway, has been the SHIFT projects, where we're looking into large-scale handling of hydrogen, both in gaseous and liquid form. They include both modeling and experimental and validation of this. Up here you see some pictures of gaseous jet fires, large scale, which could simulate in a congested space. So like also in tunnels, which might be an issue if you think about trains here in Norway. So there are several of the train lines which have lots of tunnels. So in that sense, it's important for us to know the behavior of hydrogen. Also, we've done some liquid work. I could have some videos to show, but I'm trying to be a bit brief on this now. So one point is, if you let's say you have a leakage of liquid hydrogen while refueling a ship, you would have sort of liquid hydrogen and a phase transition from liquid to gaseous on the surface of the water. So what we did was to have a liquid hydrogen jet into water and see the impacts of that. If you could have a phase transition which could be more explosive-like, those were really interesting results. You could see both with a thermal camera and also visually what happened. Even more exciting was a tank of liquid hydrogen, where you closed all the safety valves and heated this to simulate a worst case scenario. And after a long time, half an hour or so heating, the insulation and tank was damaged so much that you had an explosion of the tank. You see some pictures here. I hear some sound. I'm not quite sure where that comes from. Okay, now I'm getting more towards the case analysis and the tools we're using for that. So a model we're calling HIOPT, that's a economic optimization model. So it's looking into profits for a business case. So you can optimize the size and management of a system. So you have, it looks into both CapEx, it looks into some system limitations or boundaries. I'll come back to that in another figure, so it might be easier to see. So it's data input on parameters, which is can be cost and technology. And then you have some restraints in the modeling side, some variables to decide. And the main point is to optimize your profit of a certain business case. Based on this, we can also do sensitivity analysis and look into what's the most relevant aspects to consider when developing a project like that. So as an example here on the HIOP model, where we want to optimize the business case. So if you think about a ferry or a ship which is operating on a route, typically in Norway you would have these fjord crossings. You could have short over crossings, typically half an hour, which we now see is going to be mainly battery electric ferries. And then there's a few ones which are longer, who might be relevant to add some fuel cells to. And then you have even larger ships where we see an interest in a need for hydrogen or other hydrogen derivatives like methanol and ammonia. But the concept is here the most important. So you have an application like a ship. You have options to put in batteries, fuel cells, and hydrogen storage. And based on input, we want to design this ferry to have the best business case or profit for the operators of the ship. So the input will be the operating profile. So it will depend on how you drive or operate the ferry. When it's at K, and there is low energy. When you are looking into departure of the K, it's high energy consumption or power, and then so it varies along the crossing of a fjord or the route you're going. We also put in the service or the route timetable of this. So Monday, Tuesdays, it's 5-6 crossings. For instance, that's something we can put in, and also sort of the component or energy technical data and cost specifics are also put into there. And then out of this, we do optimize the business case design over the lifetime of the ship or over a certain year of operation of it. So typically these ferry operators, they have a contract for up to 10 years. So in that sense, it's interesting to calculate for the whole 10 years, which for instance can also include some battery swaps. So after 5 years, you might want to replace batteries or similarly fuel cells to improve the performance of it. So this model can then size for us, in the case, the size of battery, the fuel cell, and hydrogen tank. It might also say you don't need a fuel cell in this case. So if it's a short crossing and you have access to electricity, then it can be the best selection to operate purely on a battery. An example of calculations we have done. So this is data from an EU project on the ferry, which has been built by Kongsberg, or the energy system has been built. And there you have the crossing, you have the power profile, and you also have the timetable of this ferry. So what we do here, as said, is to try and design those parameters of the ship. So what our model does is to do calculations on different configurations which are possible. So you see here the number of calculations being done, and here on the y-axis you have the cost or the business case of the modeled activity or use case. So as long as we do more calculations and more configurations, you see that the total cost decrease. And at one point, we don't see any improvement. So we have found the best and the optimal configuration of this. So this example shows just 24 calculations, but typically it's hundreds or thousands of these which are being done, also because they integrate over many years. Yeah, and for specifically this calculation, we could also compare with the actual system built by Kongsberg. So we did this in retrospect, having known the input factors, and we could do some calculations and see where we ended up with our model. Okay, I can take a breath and go to the electrolyzer cell. I see there's one comment or something in the chat, but I'm not sure if we shall leave this till I'm done.
Yeah, we can just answer all questions after the presentation.
Yeah, okay, I'll do that. To the electrolyzer, and I'm going a bit into the technicalities of this. So what does an electrolyzer consist of? Components. So first of all, you have the electrolyzer cell here up to the right. I'm not going into the see, here's the Norwegian text as well. Sorry for that. It's the core of the electrolyzer, where you have the electrochemical reactions. So you add water and electricity, and from there on you split water in oxygen and hydrogen, and you also get heat out of this. Then electrolyzer stack consists of many of these cells. In the refined project and the ITM stack, there's 100 of these single cells, so there's stacked together in this type of structure. When you come to an electrolyzer system, you have some balance of plant components as well to feed the stack with water, and also to handle the flows of oxygen and hydrogen as well. And then in the end, which perhaps to some degree is where you're much more familiar than I am when you're coming to process plants and engineering of large plants like this. So this is an example of the refined plant, where you have both the electrolyzer as a core, and then you have all the additional components and process applications to handle the overall operation and processing of hydrogen. Again, on a different kind of view here, you have, of course, to have green hydrogen, you would need renewable energy. You need a rectifier to convert from AC to DC. We need to purify the water, as all the question was linked to water, so we'll come back to that also. Both of these two are then fed into the electrolyzer, which splits the water. The hydrogen coming out, and also the oxygen, has some water in it. So in the gas, so you need to separate and dry this. So first you have a separator before you have a dryer, where you absorb most of the remainings of the water. Typically, you have a compressor for distribution or storage directly into a tank. So these are the main then components of a electrolyzer process plant. Coming into the electrolyzer market and the development of this. So here you can see a development of how this has been the last 20 years or so. So the figure to the left looks into the installation capacity and the total planned of those. So if you can see, typically earlier, or at least up until the 2020, most of the electrolyzer sizes were at least in the range or below megawatt. You had the ones which were mainly larger, were on the conventional alkaline electrolyzers, and now the announced plants, and both on the end user side, but also on the electrolyzer providers, is then more on gigawatt scale. And that is also something which is seen here on the accumulated and cumulative capacities planned onwards. So I think these data are already some years old and probably outdated, because the environment changes so quickly. But sort of the plans for installing electrolyzers are incredibly ambitious. And yeah, we already see that sort of the plans are a bit higher than what's possible to implement at this stage. Core message here is that there is an interest and need for larger and more capacity of electrolyzers. Relevant to that, so we already in 2018 started REFHYNE, which is a European co-funded project. So it's within the Clean Hydrogen Partnership, one hydrogen program in the EU. At that time, Horizon 2020. Now, so the new program is called Horizon Europe. But this was funded at that time and a collaboration between Shell, the owner of the refinery, ITM Power, which supplies the electrolyzer, and then you have SINTEF, Sphera, and Element, which are doing technical, economic, and environmental analysis, dissemination of the demonstration site. So the 10 megawatt electrolyzer consists of 5 modules, 2 megawatt each. And you can see briefly the timeline, which was indicated here. So I said 2018 started. There's then the need for very thorough and revised engineering of the plant, cost development, cost estimates, and groundwork started at the site 2019. Stacks needed to be built by ITM, and in middle of 2021, the plant was inaugurated, first start of operation of the electrolyzer. A brief figure showing pictures mainly of the components. So these are mainly the same which I showed you in the earlier overview. So the core of the electrolyzer is in the electrolyzer building. So you have the stacks, transformer for the power. Into the stacks, you have water supply, the ionized water unit. You have dryers, gas separators, further drying within the handling of oxygen. And in the end, you have handling of hydrogen. And in the refinery, this electrolyzer plant is integrated with the rest of the hydrogen pipeline system at the refinery. So all hydrogen produced by the electrolyzer is fed into the industrial plant as such, and is replacing then the hydrogen from SMR. Based on a 10 megawatt project, we now also have a 100 megawatt project where we plan to upscale to a production of up to 40 tons of hydrogen per day. So in this project, we, in addition to ITM and Shell, we also have Linde on board, which are overall responsible for the engineering part of this. This project is still under development, and the investment decision is not yet taken. We expect that to be done this year. Okay, another breath. Now going into end use and demand. And this is probably not a big surprise. So you have fuel for transport and also power. You can use hydrogen for heating, both in industry and buildings. And you have it as feedstock for chemicals, or also the production processes, for instance, of steel or glass. When it comes to demand, it's been more or less stable sort of many years, so a bit below 100 megatons per year. We see and expect an increase now, But anyhow, much or most of the hydrogen is used in refineries, produced on site by steam methane reforming. Lots of it is then also used in ammonia and methanol production, as well as some metal or steel production. Then use case analysis. So I'm coming back to a system overview. What do we study when it's about electrolyzers and use cases? So we have the core electrolyzer, we have water, electricity in, which I mentioned. You can have the additional income by providing or selling heat and oxygen. So in PEM, the heat is typically low grade or 60, 70 degrees. Oxygen has some additional features or safety issues or handling issues, which easily complicates or increases the costs. So it's not often used. You of course have the output of hydrogen, which you either sell sort of continuously or internal use, or you can have an alternative additional hydrogen market externally, where you typically have compressed and stored hydrogen. At the refinery, there is a quite complex system, so I'm not going to go into details here, but you have lots of, or many more factors considering, which we are studying now in the next phases of the project. But for the case which I'm going to present to you now, so we have simplified this to input as water market, electricity market, electrolyzer, potential income of heat and oxygen, and then it's either internal or external use of hydrogen, or it can be both. I see now time-wise, I'm not going to go more into the HYOP model and how this is done, but this is in line with what I already presented on what the HYOP model does. So it optimizes the business case of profits for such a system, dimensioning the components and also giving a steer on how to operate it strategically. So what we do in this case is we use the spot price. The electricity spot prices has been chosen for Germany. I think it's 2019 numbers. You can put that into the model and see what impact that on the operation of it. So our base case when we model this is continuously 30 bar for internal use, 100 megawatt electrolyzer, 2020 costs, no income from heat and oxygen. As I said here, the spot price from 2019, and we have an unrestricted demand for it. So everything we produce is put into the refinery. And also, yes, the system can decide not to deliver hydrogen. So there is no required production of it. So here is an example. You can see to the right, the spot price varies, and then depending on how high or low the cost is, you operate or not. So the red lines indicate no operation of the electrolyzer, and the green indicates operation. So at the lower prices here to the right, you see more and more operation of the electrolyzer. So an example when it comes to variation of electricity price, the base case is the left figure, which I presented here earlier. If we increase the electricity price with 50%, what impact does that have? Of course, the net present value decreases from the base case, where you have a positive net present value of, let's say, 45 million euros. If you increase the electricity price, that impacts a lot the business case. So we're down into minus 50. If you reduce by 25%, you're all the way up to more than doubling, perhaps tripling the net present value of the concept. So not need to go into all the details of this, but you see the big variation in value of the project depending on electricity price. So here we have, as I said, 50% higher, 25% lower, and then you have fixed prices over the year. And you also here to the right, you have the average electricity price from the spot price. So from our business case analysis here, it comes to the main conclusions on that. To the right here, the blue one is the base case, and then we have done many other cases, among those on the electricity price. If we compare here, you have the next one is 2030, so it's cost projections till 2030, and you see the net present value is much better because we expect lower cost of technology. On the 5 megawatt plant, the smaller one, you would have an economics which is a bit less. So the upscaling of electrolyzers is a positive aspect of these electrolyzers case studies. You will get this. It's an open publication, so we can send you link to all of this where you can read more details about the study. But we looked into both income on heat and oxygen, combined heat, and also variation of external sales price of the hydrogen. But main conclusions and core messages are the electricity price, which is highly crucial for the business case of an electrolyzer. This was no surprise, of course, but at least here we can see the numbers and also do a sensitivity analysis of this. So hydrogen is mainly produced then when the spot price is below a break-even price. And if you have a constant electricity price, like a PPA, a power purchase agreement, you would have a higher hydrogen production, but you don't necessarily need to have a better net present value of this. So it depends on the variation on spot price, of course, the variation, and also what kind of contract we're achieving. Compression, if you are selling hydrogen to external market where you need to compress, that considerably decreases the net present value of the business case. So compression and storage is high cost and therefore should be avoided, at least in these large scale systems where you have an on-site large end consumer. In some instances, we see that if you have a smaller system, like a 5 megawatt electrolyzer, we can operate it at a higher utilization rate, sort of higher, as you see here, you have the lower figure utilization rate. So in a typical, the base case, you would operate around 75–80% of the time. And if you have smaller systems, it might be beneficial to operate have more uptime of these systems. And finally, we see already that with the expected cost reductions we see in technology, we will see an even better development of the business cases and net present values of analyzed cases as we have looked at now. Okay, that was perhaps lots of information in one run, but I hope it wasn't too much, and we probably should open up for some questions on this.
Yeah, thank you, Anders. It was very interesting, and we see 20+ questions. But before we move to the Q&A session, do you need some break? Maybe 1 or 2 minutes for like to take a glass of water? Maybe?
I have my water here, so if it's okay with you, I can.
Okay. So, Anders, we have 20 plus questions. So I'll try to read them. And yeah, please keep it short, simple when it's possible.
Yeah.
First question, can you please comment on the feasibility and impact on green hydrogen at scale in places with fresh water constraints?
Yeah, that is of course a relevant aspect, and if I'm to answer short, relatively speaking, when it comes to sort of hydrogen or water consumption in many other areas or uses, actually the consumption of water is relatively small. There might be areas, of course, where it will be an issue, but also the cost of preparing the water is relatively limited. So in general, that's not a big problem, but of course there are areas which will have some issues.
Thank you. Second question from Prahar. Can creation of hydrogen and oxygen via electrolysis increase the dissolved oxygen in the bulk of water?
Yeah, it depends on how you design your system, how these process components and flows are handled. But of course, oxygen dissolved in water can be an issue, especially also if you design your system so that you have water with dissolved hydrogen and mix. Yeah, I'm not sure it can. The concept itself can increase the dissolved oxygen amount, but in water. But at least if you have a system, you have to take care of sort of oxygen and hydrogen flows.
Question from Alexei. Do you use a fiber optic monitoring in any hydrogen-related project application? Fuel cell pipelines plants, for example, for leak detection, temperature monitoring, pipeline integrity, etc.
Yeah, I'm not too familiar in specifics on those technologies, but I'm sure some of that should be fiber optic, but yeah, I can't say.
Yeah, thank you. The question from Bob Pearson, it's also like our officer of the SPE Hydrogen Technical Section. So does SINTEF anticipate significant improvements and cost reduction in hydrogen storage and transport system?
Yeah, that's also difficult questions. In general, there will be improvements, of course, in cost reductions, but it's very difficult to say if they will be significant. It's in general, you expect if not a linear, but at least a typical decrease of cost, but then you might have these technology shifts which can reduce this more in the shorter term, but that's very difficult to predict. What we see now is sort of the use of other hydrogen carriers as storage and in transport, like ammonia or methanol, or you also have this liquid hydrogen compounds, organic compounds, which are being developed. So several options.
The next question from S. McNeil. The Russian invasion of Ukraine has seen power prices rise dramatically, along with inflation. Have you not updated the economics results with the data from 2022-2023?
No, we haven't done, said on these analysis, we used the 2019 numbers, but we also, as you saw, a sensitivity analysis on higher cost increasing by 50%. And of course, in general, higher prices have lots of impact on production cost of green hydrogen. So the business case has severely decreased, or the value has decreased lots. And yeah, it's just the fact. So all new business cases or projects need to be recalculated based on these new electricity prices.
Got it. Next question from Prahar. Are we in a position where we can tolerate hardness, alkalinity, and salinity in the feed water? And if so, to what extent?
Well, typically, at least for PEM electrolyzers, it's need to be very pure and also deionized. And as I said earlier, my understanding is that the cost of water treatment is relatively low. So as long as you have water available, even if it's salt water, this can be at a relatively low price, cleaned and prepared for use in electrolyzers. So there isn't much need to really do much more development there, actually.
Next question, it's more like words of gratitude. Thank you for the presentation. Do you have or are you aware of any cost comparison vs battery storage system?
I don't have anything at hand now, but there are many studies looking into that, so I'm sure it should be possible to find. It's an issue of size and duration of storage. So that's the parameters. How much batteries do you need to sort of cover the need? In many cases, batteries and efficiency advantage makes it highly prioritized in many of those cases. We see here in Norway that if there's a limitation in grid to charge ferries, they install large battery packs on the quay to be able to charge the ferries at the higher capacity than you could directly via the grid. So batteries are very efficient and at a relatively okay price for that use.
Yeah, thank you. Next question from Fion. So production cost is a key challenge in transitioning to hydrogen-based energy carriers. So how can materials and scaling help?
What we see now, for instance, in the Refine project, which is a 10 megawatt PEM electrolyzer, so that the biggest one in Europe, and also when it comes to the involved partners, it's the biggest they have been involved in developing. And we see already a huge improvement and potential for cost reductions in the next system. So the 10 megawatt project, as listed here, was at the cost of more than 20 million euros. We expect that the next one you could build for half of that price. So there is lots of learnings, and even if you then upscale from this, we now know how to operate and build a 10 megawatt. Of course, we will need some development for the 100 megawatt, but upscaling that again, you will have much less cost per kilowatt electrolyzer installed capacity. And similarly, when it comes to manufacturing capacities, so in electrolyzers, you have much those manual assembly lines now, or semi-manual. And when you get those optimized with robots and other types of manufacturing technology, then you'll be able to reduce lots of those technology costs as well.
Mm-hmm. Thank you. One more question from Ashish. Have you run any sensitiveness to include varying cost for high salinity salt water treatment?
No, we haven't done that. And as I said earlier, as far as our studies or our numbers say, there isn't too much sensitivities or too much impact on the water treatment process on the overall costs. So I know there's quite some work on this also on direct seawater electrolysis, but yeah, in our case we haven't looked more into that.
So we have 15 plus question from the registration form Zoom, like they just people left their question. So from Cesar, what do you think about geological hydrogen have to be connected to green hydrogen? So like tricky question.
Yeah, geological, you mean then this natural hydrogen? That I do not know too much about. That came to me as a big surprise that there's lots of hydrogen underground. So I can't say much about that. I don't know.
Okay. Next one from Hermes. Material selection for hydrogen injection and transportation.
Was that the question, or sort of what kind of materials is needed for it, or?
That was a question.
No, I think there's high quality steel and plastics what's used in when it comes to handling hydrogen.
Okay, from Bob, what is the hydrogen volume-to-volume compression requirements that obtains the equivalent energy value of 1 cubic meter of natural gas? Where you calculating?
I cannot give that number now, but it's of course the volumetric energy density of hydrogen is difficult. So that's also why on mobility and transportation you see up to 700 bars storage tanks, and also in our case the truck project you'll have Daimler who will operate on liquid hydrogen tanks. So then you're getting up to some good energy density storage.
Yeah, question from Raman. What would be the perspectives for Mexico and Central American region? Like it's like out of your region, but still. Can you handle this question?
Yeah, no, it's personally, I'm not sure how much, at least in the coming decade or decades, there will be on import and export of hydrogen across continents. There is quite a cost on transporting it, so I think the main business will be then to convert or make ammonia or methanol or e-fuels type based on green hydrogen. That can be a business case, and in that sense, wherever you have cheap electricity, that's the best places to develop these kinds of projects. And of course, middle, central, south of America have to some extent good conditions for that. So there's lots of activities going on there as well.
Thank you. So what question from Carl, what synergies from solar, wind, geothermal interface can support hydrogen economical production or not?
Geothermal, I'm not that sure. I have to think. When it comes to solar and wind, of course, that is to some extent complementary. So you can use both waste and solar to increase capacity in the summer, at least what I'm aware of here in Norway. So there's much more wind in winter time, and of course more sun in the summertime. So that way you can even out a bit the access to electricity. Geothermal, I must say I cannot say too much about that.
Yeah, question from Tariq. Economic viability of green hydrogen is not realistic. Who will pay for this?
Yeah, currently it's a very high price if you look into the current cost without subsidies and anything. So in this case, in general, you really need to develop a market, and our studies also shows, or is an example on how what is needed to have cost reductions and how this can be done in future projects and coming years. So the main driver is the need for clean technologies and clean fuels and energy carriers. So that's something which hydrogen can provide, and for many cases there are no other alternatives. So in one way or another we need to transition to this in those cases. So it's seen hydrogen can be produced at a very low cost in certain regions and business cases, and we just need to find and develop those. But there's an interest both politically and industrial for developing the market.
Question from Sheifu. What will the future of hydrogen power and how it compete with the other source of power?
If hydrogen power, then of course I would then interpret that as using hydrogen to power some stationary applications. Of course, hydrogen is only an energy carrier, so in that sense, not sort of a power source, but hydrogen for stationary power production, that is also being investigated. Of course, it again depends on the business case. So what do you do? So there's plans for power plants in Germany and other places as well for large scale systems. But as mentioned previously as well, if hydrogen is costly, then these power plants will also be costly. So
Thank you. Question from Rosen. What are the main barriers for green hydrogen production, like challenges?
Well, now as also mentioned, high power prices, the electricity prices are very negative for the green hydrogen business case. In addition, what has slowed the overall transition or the introduction of green hydrogen into the market has been the regulations, the lack of those when it comes to support schemes. So there are these EU regulations, the RED II, which is called, and that has been delayed a couple of years. Many companies have been waiting for that to get more understanding, better understanding and knowledge on how the economics of such systems will be. So the uncertainty of the financial and also the legal regulations has had a huge impact the last couple of years, and I think I can say that it's really delayed the whole thing with considerable time. The technology itself is mature. Of course, you can improve the technology, but and lower the cost, but that's more depending on the market than on the technology as such.
Thank you. question from Carl. What is your prediction for hydrogen industry penetration in energy transportation industry?
Yeah, it's difficult because it's been some up and down on the hydrogen for the several decades. I've been joining a couple of them, and there is a big difference now this time because the political and industrial push is much higher than earlier. So the interest has increased a lot. The exact timing, so we see now there's been a delay in many of the activities the last 3-4 years, which were expected to take off. It's hard for me to predict something. We always say that next year, in a couple of years, you will see a huge increase in it. As mentioned, there's quite some projects being put on hold to wait for the regulations, which have been expected. There are several new incentives now coming into play, like this European Hydrogen Bank, which will make it more predictive hydrogen prices for end users. That's been some of the issues now. So many are ready to produce and sell hydrogen, but end users are waiting to have some more security on the cost of hydrogen before they invest in usage.
Yeah, question. What are the major barriers of green hydrogen application in energy intensive industries like refineries, steel, and cement?
Yeah, main problem is the economics, as I said. So we really need to upscale to get the low cost, and they're used to very low cost hydrogen. It's like in any other cases, it's about cost. And if you can turn it around and say the upside of these large industrial uses is that they are the perfect site for starting up big plants. So if you have a huge consumption of hydrogen, you don't have an issue with finding end users of these. So in that sense, like a refinery is ideal for demonstrations and early plants. But of course, you need to be aware of the higher costs.
Question from Yoshi Fumi. Which is the most competitive blue hydrogen project? Which is the most competitive green hydrogen project?
Specifically on projects or those two compared? I think the issue with blue is that there's an enormous size needed. You need much larger volumes than with green hydrogen. So for the whole infrastructure, potential is huge there, and there's lots of interest in, for instance, from Norway. So if we're able to capture and store CO2, that's great, but you then need to have an infrastructure to handle and store CO2. On the green hydrogen side, it's upscaling the market, which is the major issue now.
Thank you. Question from Ashish. How does one address green hydrogen at scale when there is a constraint of fresh water? It was like, actually it was right. It was. Yes.
I see also that there are projects being developed in deserts. So in one or other way, I assume they also know how to get water there.
Agree. So next question: what are the challenges of to producing green hydrogen from sources like brine, seawater with minimum pretreatment? Right, singular.
Yeah, thank you.
Yeah, and one more from Asan. What time period do you expect hydrogen refueling infrastructure to be scaled to the level that HD trucks can switch to hydrogen?
Yeah, I just saw today Total, which is one of the partners in our H2 Accelerate project. So they have a collaboration with Air Liquide in France. So their latest plans are to install 100 refueling stations for heavy-duty trucks by within 10 years. Of course, it's a long time frame, but I think this is also aligned with the availability of hydrogen trucks. So it's being developed. There are several pilot projects like H2 Accelerate Truck, but the fueling stations and truck availability need to be developed together. And I think in that time frame, as announced today by Air Liquide and Total, 10 years for 100 stations, and if you then include other actors, which are a couple of handfuls, I think, if those are realistic, you would see quite a good infrastructure development within the next 10 years of hydrogen.
Yeah, thank you. From Ashish, one more question. Can existing natural gas or domestic gas pipelines carry hydrogen? To what extent?
Yeah, I think to my understanding, sort of above sea or above water pipelines can more easily be converted to hydrogen. So from natural gas, issue is the capacity. So due to different properties of natural gas and hydrogen, you will have less energy transport, of course, capacity of it, but most of the above ground pipeline network can be used with more or less pre-treatment. And then, but the subsea pipelines are more difficult, although it's also possible, but it's not straightforward to do that.
Mm-hmm. Okay. From Bob Pilko, thank you for the presentation. What is the cost comparison between green wind hydrogen versus natural gas derived hydrogen?
Yeah, of course, it's difficult to have a one-to-one comparison and knowing both sizes, location, and all of that. But if you have sort of hydrogen from SMR in the range of 1 to 2 euros per kilogram, green hydrogen now with high electricity prices and low volumes, it will probably be more up to 10 euros per kilogram. With the option of seeing studies down to also in the range of 2-3 euros per kilogram. So it's at least potential to get down to those costs, but that is depending on many factors, and we need to see an upscaling of the market. When it comes to blue hydrogen, I think also in somewhat similar range, depending on size and availability of capturing and especially storage of CO2, down to 2 euros per kilogram is also should be possible.
Anders, and the last question. And to count, it's like I assume it's like up to 30 question was from Bob Pearson. Can you comment on the rate of battery improvements eroding the hydrogen market in heavy transport application?
Some general reflections perhaps, and as I said, with those projects we have, so we've had this hydrogen trucks in Trondheim now for 5-6 years. One thing is that there's been technical challenges, so it's a relatively new technology. It's up here in Norway with snow and cold and challenging conditions. So there's been some ups and downs on that. Then of course you need your hydrogen station. This company, grocery retailer, they have built their own station, so they have availability on site. They have fueling for passenger cars, but also for forklift trucks in their facility. So they have a combined usage of the hydrogen, but in general, so now there's a very high cost of all of this package. So that's a challenge. And then what we also see is that the availability of trucks is also an issue, because there's so high interest in joining demonstrations and pilots, that it's much more than the truck OEMs have available or are willing to put out in the market at an early stage. So I think now there's much more interest in trucks than possible to roll out.
Yeah, we always question. Yeah, so it was a pleasure to see many familiar faces from names from SPE that I know. For some like case studies. Yeah. Anders, it was like a pleasure for us to listen to your presentation, because hydrogen is becoming as a part of energy industry, like, and it's